Hello friends, welcome to the channel. Welcome to one more lecture related to series magnetic circuit. So in this lecture also we are going to have one more numerical. Okay, a very important numerical. You can see in the figure. You can have the question in this screen. What is the question here? See, a rectangular iron core shown in figure has a mean length of magnetic circuit of 100 cm, cross section of 2 cm by 2 cm, and relative permeability of 1450. A cutoff size 5 mm in the core has been made. The three coils A, B and C on the core have number of turns NA, NB and NC given, and the respective currents flowing are also given. The directions of current are shown in figure. Find the air flux neglecting fringing of flux. Okay, so this is the question. So here the arrangement has been given in this rectangular bar, and here we have three number of coils. Okay, in which different number of turns for all the coils, that is A, B, and C coils have been given. Number of turns are given. Current flowing, the value of current has been given for each value, each coil. Okay, the length of the rectangular shape is given. Cross sectional area is given. Relative permeability of the material is given, and there is a air gap here, as you can see in the figure, that is given as 5. Okay, we have to calculate what? We have to calculate the flux circulating through this circuit. Okay, so how to go for the solution? So see, first of all, we will go for the draw of equivalent circuit of this figure. Okay, it is very important. This question is very important. It is a conceptual question. Okay, so first we will have that equivalent circuit process. So in the equivalent circuit, you can see that this figure has three coils A, B, and C. Three coils. Okay. So when we will draw the equivalent circuit, we will have three sources, right? As we have discussed in the previous classes, that each coil gives certain amount of MMF. So if this is giving me some MMF, this will also give some MMF. This will also give some MMF. Okay. So when I go to draw the equivalent circuit, I will have three MMFs. Okay, so this is the MMF of coil A, MMF of coil B, and MMF of coil C. Right? Now we have to check the direction of this MMF, the polarity of this MMF. Okay, so we have seen in the previous lecture that how to go check the direction of this magnetic field. So that can be taken by the thumb rule. Okay, Ampere's law gives the thumb rule with the help of, if the current direction is given by the finger direction, then the direction of magnetic field will be given by thumb direction. Right? So here, suppose this is the given coil on which I have to work. Right? So the direction of current is being given. So according to that, this is the direction of current. Right? So if I place my right hand here, so this is the direction for the current. So what is the direction for the magnetic field? It is upward. Right? According to the thumb direction. So this is the direction of F. Okay, that means the upper can be positive, lower can be taken as negative. So this is the polarity for this source. Right? Now similarly we have to go for coil B. So coil B, can you see the direction of current is given like this. Okay, it is coming from the second side of this iron rectangular shape. So this is the direction of current. So this is the direction of current. It is coming like this. So this is the given direction of current. Okay, so according to that, again I am getting MMF in upward direction. So this is the direction for MMF through the coil B. So the polarity will be this. Okay, now for the last section, that is coil C. So here, according to the current direction is coming like this. Whatever is the given direction, I have shown you. Okay, so you can see here, this is the direction of current. So current is coming like this. Okay. So according to that, what is the angular direction? It is right towards the right direction. So this is the direction of FC. Okay. So I can take the source direction or polarity like this. Right? So this is the polarity for FA, FB and FC, and we have taken that direction according to the thumb's rule of the Ampere's law for getting the direction of magnetic field. Right? Now this arrangement has two materials. First is the given material and second is the air. So what will I have in the equivalent diagram? I will have two elements. First is of iron ring and second is of air. Okay, and here we have flux which is circulating through this arrangement, right? So this is the equivalent diagram for this given question. And here, all the related data we have been given, we have to calculate the value of this flux. Okay, we have to get the value of this flux, right? So how to get that value? See, we have the formula F equals to phi into S, where S is the equivalent reluctance, summation of these two. Okay, so I have to get the value of reluctance, I have to get the value of MMF, then I can get the value of flux. Right? So reluctance can be calculated with the help of the given length, cross-sectional area, and relative permeability. Okay, but how to calculate the MMF? So MMF calculation can be done with the help of F into F. Okay, number of turns and current value has been given for each one. Right? But now in this section we are having three number of MMFs. Okay, so we have to take the equivalent MMF by solving it. In the similar way, how we used to do in electric circuit. Okay, so first we will check that what is the total MMF with the help of N into I. Okay, and then we will go for the calculation of reluctance. Right? So let's check what is the value of MMF for coil A. So that is what? Number of turns of coil A into current through the coil A. So that value is how much? So NA is 325. And what is the current value through the coil A? That is 1.5. Okay. Similarly, we can check for the FB and FC also. Right? So let's check what is the answer coming here. Right? So this is the values for MMF of coil A, coil B, and coil C. Simple calculation. Now let's check what is the effective MMF. Is the total MMF. Okay. So here I have shown the polarity, and that has been shown to get the total MMF also. Okay. So according to this, see, this is the direction I have assumed for the flux flow. So I will go with the help of that. So according to that, FA will be positive according to this direction. Now we are coming toward this. So FB will be taken as negative and FC is also negative. Okay. This is the simple polarity I have taken as we used to take the equivalent diagram for voltage sources. Right. So this is the direction positive. The direction is coming negative because the direction of source is upward and my analysis direction is downward. So it is going opposite. Okay. Similarly with this. So we are getting minus FB and minus FC. So by keeping that all value here, so what I am getting here, this is 502.5 minus 2400 minus 1800. Okay, so what is the effective MMF we are getting here? That is so we are getting MMF as minus 3697.5 ampere turns. Okay, so this is the effective value of MMF. That is the total MMF. Right? Now let's check what is the reluctance of this given question. So reluctance I have two types, that is of iron ring and another of air. Okay, so first we'll check what is the reluctance of iron ring. So for that the formula will be the length of iron ring divided by mu naught mu r into cross section area. Okay, so what is the length of iron ring here? See, it is given as 100 centimeter, and this 100 centimeter length is given for the complete section where I have a air gap of 5 mm. Okay, so what will be the effective length? That is 100 centimeter. Okay, minus 2 because of we are converting into meter minus what is this 5 mm. Okay, so minus 5 converting again into meter. So this will be the effective length of the iron material. Okay, total length minus air length. Right? Now, what is the mu naught? Let me know that is 4 pi into 10 to the power minus 7. What is mu r? Mu r has been given as 1450. What is the cross sectional area? Cross sectional area is given as 2 by 2 centimeters square. That is 4 into 10 to the power minus 4 converted into meter. Okay, so this is the value for iron reluctance. Similarly, we can get the value for air reluctance. Okay, so let's check what is the answer given here. Okay, so this is the value we are getting for iron reluctance. Similarly, we can get the value of air gap reluctance, that is length of air gap, that is given as 5 mm divided by mu naught into mu r. Mu r is what? That is 1. Because we are working on air gap into cross sectional area, that is 4 into 10 to the power minus 1. Okay, so this is the value for iron reluctance and air gap reluctance. Okay, so what we have to calculate? We have to calculate the value of flux. So flux can be taken as what? Total MMF, what we have calculated just now, divided by total reluctance, that is the summation of Si plus Hg. Right? So So by keeping that on value, we can see what is the value we are getting, that is minus 3697.5 divided by the total reluctance is 1.365 and reluctance plus 9.947 into 10 to the power 6. Okay, so when you go for the solution, the answer is coming as minus 0.327 milliampere. Okay, so the answer is minus 0.327 milliampere. Right? Why we are getting plus and negative? Because the total MMF is coming as negative. And why we are getting this negative? The negative sign represents your assumption direction. Is I have assumed for the direction of flux. Okay, so the direction is opposite to the actual level. That means flux is circulating in this direction. That is anti-clockwise. Okay, so that negative value represents the same thing as it is representing in the current. Right? So this is the complete solution for this particular question. This is a very important question to develop with the concept that how to use the thumb rule and how to go for the solution. Okay, so hope you are getting all the understanding here. If you have any doubt, you can ask me in the comment box. I am waiting for your comments. Okay, thank you. Thanks for watching.